So Assalamualaikum and good day everyone. For Muslims, I wish you happy fasting. Okay, so selamat puasa. Alright. So this week, we already into week 5, and I'm sorry because I'm late to upload this video because actually yesterday our class supposed is on Tuesday, right? So actually Tuesday is a public holiday for Malacca, which is Malacca take the holiday for our Ramadan. So means that I hold the video first. So means so I will upload this video today, which is a Wednesday. Okay. Alright, so without further ado, we will proceed with the last subtopic. Okay, last subtopic in chapter 1. Okay, so basically kalau maybe for you yang tak go through the teaching plan, okay, actually we just only have 3 chapters. Okay, so so this is last subtopic for chapter 1. So what we will learn today is about local extrema. Okay, the title is local extrema, or maybe some textbook it says local extremum, but what's mean by extrema here? So extrema here is represent either minimum or maximum. Okay, so local extrema here is represent local minimum or local maximum. Okay, clear? Alright, so in this topics, okay, this is my notes actually. Okay, so you can refer to slides. Okay, so in this topic we will learn we have 2 tests. Okay, 2 tests. So the first one we call it as first derivative test, and of course the second one we have a second derivative test. Okay, so I will go through the first derivative test first. Okay. Okay, so what's the derivative test objective of test? Objective of the first derivative test. So the objective of first derivative test is to determine critical point. Okay, so now what is the critical point? Okay, so I will show I will show you what's the critical point through example later on. But for now, I will write down first the steps of by you doing what we call a first derivative test. Okay, so I just write down the step first. So the first step is you need to find fx. So means that you need to differentiate with respect to x, right? And then you equate this fx equal to 0, and you do it the same thing for y, which is you will differentiate your equation with respect to y, and then you equate to 0. So you have 2 equations here. Okay, so second step is simultaneous. Okay, persamaan serentak. Okay, simultaneous equation or substitution. Okay, so what do means by these 2 is, okay, from here, from step number 1, you have 2 equation. Okay, clearly that you can see that you have 2 equation, 1 and 2, and then inside these 2 equation they have an unknown, maybe a and b. Okay, I just let a and b. So by what objective just now? Okay, we want to determine critical point. So what's meant by critical point here is the value of a and b. Okay, the value of a and b. So how to get a and b? So you need to use a simultaneous equation, or maybe you can use substitution. Okay, alright. So step number 3, of course lah, you akan dapatlah value kat sini. So this value we call it as critical point. Okay, this value is critical point. So now I will show the example. Okay, so example 1. Okay, determine the critical point of fxy 3x squared minus 2xy plus y squared minus 8y And then consequently determine whether okay, this one we hold it first, okay? Later I will continue. Okay, so the first question asks you to find or to determine the critical points of equation given here is 3x squared minus 2xy plus y squared minus 8y. So you just follow the steps, okay? So we do it for step 1 first. So step 1 means you need to find your fx. So you need to differentiate this equation with respect to x, okay? With respect to x. So suppose you should get 6x minus 2y, okay? 6x minus 2y. And you do it the same thing for y. Okay, so you have here negative 2x plus 2y minus 8. And these two equations must equal to 0. Okay? Alright, so you can see that you have x and y unknown here. So there is your objective. You want to find the value for x and y. So what we do next is simultaneous equation or substitution. Okay, so you have two equations here. So 6x minus 2y equal to 0. And another one is negative 2x plus 2y equal to 8. Okay, because this is just a constant, so I bring to the right hand side here. Okay, next what we can do here, you can see that this is 2y. Okay, both are 2y, so they have nothing. Kalau you nak buat, if you want to choose x also tak ada masalah. But you need to multiply with 3 lah for the second equation here to make it is equal to with 6. Okay, so that one I hope that you already you still remember lah how to solve simultaneous. Okay, so I choose this one. Why? So this one since the what you call the sign is negative and positive, which is not equal, so that means the operation here is plus. So 6x minus lah. Okay, 4x equal to 8, x equal to 2. And then you just substitute back this x equal to 2 to either one lah. Tak kisah, I mean each mana-mana pun. So let's say I choose equation 1. So I have here 12 minus 2y equal to 0. So that means 2y equal to 12, y equal to 6. Okay, therefore step number 3, okay, step number 3, my answer lah, okay, x, y equal to 2, 6 is a critical point. So this is my critical point. Okay. Okay, this is my critical point. Alright. Okay. Okay, so I think okay, let me find another example if we have here. Okay, yep. Okay, alright. I have one more equation. Okay, I give you one more example, okay? Right, so the equation asks you to locate, okay, locate all the critical points of fxy equal to xy plus x cubed over 3 minus y squared over 2 minus 2y plus 4. Okay, right, so this is the question. Locate all the critical point of blah blah blah. Okay, so what we do first, find out fx. Okay, find the fx. So you have y plus 3x squared. Okay, y plus x squared. Okay, and then fy. What is your fy here? It will be x minus y minus 2. Okay, alright. And this equation you must be equal to 0. Okay, step number 2, we will do the simultaneous equation. Okay, simultaneous. But okay, if you can see that for me because the what we call the equation 1 and 2 is not in the same path ataupun in same level. For example, you can see that example 1 they have x square here, but for fy, for the second equation, they have no x square. I mean the highest order is just 1. The highest power here is only 1. So dia punya level tu not same with par lah. Okay, tak sama. So what we do, selain others than simultaneous, you can use a substitution, right? So for this type, I think I prefer that if you have a question like this lah, macam means that tak sama power, you use substitution. Okay, so I will show you how to use substitution here. So just let's say I declare this one is equation 1, equation 2. So I choose either one. Let's say I choose equation 2. Okay, this is equation 2, right? So I choose x. Kalau masukkan x, tak nak lah. Masukkan y. Okay, let's say I choose y equal to, bring here, so x minus 2. So y will be equal to x minus 2. Actually, it's up to you. If you want to use x also, tak masalah. So x equal to y plus 2 lah, kan? Okay, either one lah. Okay, let's say I choose this one. Okay, what we do next? So I declare this is as equation 3. So just substitute this one, into equation 1. Okay, jangan masuk equation 2. So you use equation 2 to get this one, right? So now this equation 3 substitute into equation 1. So what we have here, it will be x minus 2 plus x squared equal to 0. Kan? Okay. So how to get your x? So since they have x squared and then this one is the pattern of quadratic, so you can use your calculator to find it. Okay, so it will be x minus 1x plus 2 equal to 0. So that means your x here is 1 and x negative 2. So you can see, right? You can compare with the previous example. The previous example, your x is just only 1, 2. Okay, only one value only lah, which is 2. But for this example, you have 2 value of x. Okay, this is the hint, not the hint lah, the tips. How you know that how many critical point that will exist in this question ataupun in the question that given to you. Okay, you must refer to your equation fx or fy lah. Okay, either one. You must refer to the power. Okay, you can see that for fx here, you have the highest power here is 2, right? So that means it will be 2 critical point. That's the keyword lah. That's the keyword. So if you can see just now for the previous example, fx is just only fx, right? It just only consists of 6x, which is the power is only 1. So that's why we have only 1 critical point. So can you imagine? Can you if you have a question and then after you differentiate fx or fy, you get the highest power is 3 there. So means that your critical point will be 3. Okay, will be 3. Right? Alright, so now your s1 is 1, your s2 is negative 2. So you just substitute this. Okay, means that kat sini you ada 2 value, eh? So x1 and x negative 2. Okay, so since we have 2 values, so you need to substitute these 2 value into this equation lah. Sebab tadi you dah guna ni. So sekarang kita nak masukkan dekat sini to get your y. Okay, so x just now is 1, so your y is still y minus 2 equal to 0. Okay, so now what is your y here? What is your y? Okay, you can just substitute directly lah into equation 3. Okay, tak perlu pun tengok nombor 2 tadi. Okay, alright, okay. So this is your equation. Alright, so now substitute this into this one. This one is equation 3, okay? Equation 3. So 1 minus 2, so negative 1. Okay, this one, how about this one? It will be negative 2, negative 2 will be negative 4. So therefore, step number 3, okay, therefore, your critical point now is equal to, okay, just now is 1, you get the y is negative 1, and negative 2, negative 4. So this is your critical points. Okay? Okay, class? So yeah, so this is what we call as a first derivative test. So first derivative test, it means that you differentiate only once And the objective of first derivative test is to get the critical point only. Okay, critical point only. Why? Because later on in the next video, I will show you the second derivative test, which is to determine whether your critical point is local max, local mean, or saddle point. Okay, class. So yeah, see you in the next video. Dah.